We're now going to use this slide to prove the formula for the sum of the interior angles of any polygon. Recall, a polygon is a two-dimensional figure bounded by straight line segments. So the simplest polygon is a triangle. It's bounded by three line segments. Then the next one is called a quadrilateral. It's bounded by four line segments. The next one is a pentagon. It's bounded by five line segments. The next one is a hexagon. It's bounded by six line segments. Now there is a formula. Some of you are familiar with it. If the number of sides is n, then the sum of all the n angles is equal to n minus 2. Let's see if I can write it here. This is the formula that some of you have learned. N minus 2 times 180 degrees. So this is the formula. If the number of sides of a polygon is n, then the sum of the n angles is equal to n minus 2 times 180 degrees. In this case, in the case of quadrilateral, n is going to be 4. In the case of triangle, n is going to be 3. In the case of pentagon, n is going to be 5. In the case of hexagon, n is going to be 6. And heptagon is the seven-sided figure, polygon. And of course, in the case of heptagon, it's going to be 7. So how do we prove that the sum of the interior angles of any polygon is equal to n minus 2 times 180 degrees, where n is the number of sides? Now, we know that the sum of the three angles of any triangle is 180 degrees. That's going to come in very handy. We know that. We can prove it, but we're going to assume we know how to prove it, and we're going to use it here. So if you add the three angles of any triangle, the sum is going to be 180 degrees. Now, take a look at this. You can take a quadrilateral, the next polygon up, and you can split it into two triangles. So these three angles will add up to 180 degrees, and these three angles will also add up to 180 degrees. Okay, if you take a pentagon, you can split it into three triangles, three non-overlapping triangles. If you take a hexagon, you can split it into four non-overlapping triangles. And the pattern continues. If you had a heptagon, a seven-sided polygon, you will be able to split it into five triangles. And sum of the angles of each triangle is 180 degrees. So what do we have here? For the triangle, it's pretty simple. If you have three sides, then the sum of the angles is 1 times 180 degrees. If you have a quadrilateral, which can be split, you have four sides for your quadrilateral. A four-sided polygon can be split into two triangles, and the sum of the angles of your quadrilateral is 2 times 180 degrees. A pentagon has five sides. It can be split into three triangles, so sum of the angles of a pentagon has to be 3 times 180 degrees. If it's a hexagon has six sides. It can be split into four triangles, and sum of the angles of those four triangles are really equal to sum of the angles of the hexagon, so it's 4 times 180 degrees. So if you see the pattern, you can actually go ahead and generalize it for an n-sided polygon. And here is the formula for the n-sided polygon. For the n-sided polygon, if the polygon has n sides, where n could be anything, any integer larger than or equal to 3, 4, 5, 6, 7, 8, 9, 10, the sum of the angles is going to be n minus 2 times 180 degrees. This is an important formula. It'll come in very handy. And on the next slide, we're going to solve a couple of problems involving the formula. So let's take a look at an example. How do we find the sum of the interior angles of a polygon with 9 sides? Remember, the formula that we just proved says sum of the interior angles of a polygon with n sides is 180 times n minus 2. And since n in this problem is 9, we can do this. 9 minus 2 is 7. times 180 degrees. And I'll use my calculator for that. And I'm getting degrees. That's my answer. So sum of the 9 interior angles, if you add all the 9 angles of a 9-sided polygon, the total sum is going to be 1260 degrees. Let's take a look at another example. This time we are being asked to find the measure of each angle of a regular polygon with 200 sides. A regular polygon has all angles congruent and all sides congruent. So in this polygon, I can easily find the sum of the 200 angles. So let's go ahead and do that. But we need to find the measure of each angle, not all the 200 angles. So our formula is n minus 2 times 180 degrees. N happens to be 200. And 200 minus 2 is 198. And again, I'm going to use my calculator. 198 times 180 is a large number, 35,640. Now, let me put the equal sign here. All right, so this is in degrees. This is the measure or the sum of all 200 angles. Now, if the polygon is regular, all the 200 angles are congruent, and I'm supposed to find the measure of each angle. So all I need to do is take this number and divide it by 200. Divided by 200. And I'm going to get 178.2. That's the measure of each angle of a regular polygon with 200 sides in degrees. That's my answer.